Good morning, this is your stats sensei, Mr. Spensei, and we're going to run a hypothesis test on a paired data on number of razor shaves that you can get. All right, so this is the same problem that we did for the confidence interval. So a consumer group compared the longevity of two types of razor blades, an inexpensive generic and a more expensive name brand. The consumer group was interested in testing the manufacturer's claim that the name brand expensive blades remain sharper longer. Okay, so we think the name brand is going to be sharper longer. We need to keep that and we need to keep that in our minds. Then the generic razor blade. 10 men, all right, who shave regularly were randomly assigned to either the generic blade or the name brand blade out of a group of more than 1,000 who shave regularly. After the blade went dull, the men shaved with the other blade. Ooh, so after the blade went dull, the men shaved with the other blade. So they swapped blades, right? So they did once with the generic, once with the name brand, and went back and forth. The number of shaves obtained before a blade became too dull to provide a close shave was recorded for each blade in the table below. The differences are normally distributed. That's important. Test to determine whether or not the name brand blade lasts longer at an alpha equals 0.07. Okay, so we have an alpha of 0.07 here. Our parameter, well, let mu d equal the true population mean of the differences. And by the way, the reason we have the mu d is because this was paired. We know it's paired because they were tested twice. And we're talking about the true population mean of the differences because we're actually going to subtract these two. All right, we're going to subtract these two in order to do that. True population mean of the differences in the number of shaves. And we have to give the order. Super important because that impacts the way we write our hypothesis. So in the number of shaves, and there's not a right or wrong, we just have to say which way we're going to go. And this time I'm just go generic minus name brand. Why the generic showed up first? Generic minus name brand. All right, we're going to need to come back to that in just a second. So the null is very easy. For a paired, the null is that there's actually no difference. Well, the alternative is where we have to be careful. Is there a difference or not? Well, in this case, we're going to say that he said that the name brand will last longer. So this is going to be longer. This is going to be shorter. So when I think about that, if I pick a number, let's just say 100, this has to be shorter than 100, which would be, let's say, maybe 80. So that tells me my shorter is less than longer. So this tells me my direction. So I should end up with a mean difference of less than 0. I'm going to go ahead and start my conditions. The first condition is random sample. And we actually have a random sample of 10. So of 10, and that was given. And it's 10 pairs. Or 10, we have 20 data points. We have 10 pairs. The next thing, differences are independent. This probably needs a longer explanation, but because it's randomly assigned, this guy shaving with his razor should not impact this guy shaving over here. N needs to be less than 10%. Well, N is 10. So in this case, it's just 10 times 10 equals 100, which happens to be less than 1,000. Number 4, our sample size is not large enough to be normal by central limit theorem, but fortunately they told us the differences are normally distributed. Differences are normal, and that's given. So all these conditions have been checked and verified, so we're good with those. Our formula, well, T equals X bar. We need D's because we're taking the differences. But on the calculator, we'll still go to the same spot and it'll still work the same way. Draw. Well, I don't know very much yet, but we'll go ahead and start. I know the mean is at 0. And I know I should see, hey, this is less than, so I should end up with a X bar somewhere over here, but we'll see what happens. Well, we know our mean is 0. We know our sample size is 10. We know we're shading here. So I need the X bar and the sample standard deviation. Well, there we go. I've input the data, and here's the way I did that. I went to stat, and I pressed edit, and I entered the data in L1 and L2. I've already checked my check figures, but I'll check one of them just to show you how I did it. Stat calc, one variable stats. And if I wanted to check L1, second one, and I find 107.1 and my standard deviation is 14.05. And that's what I have there. But I'm not looking for these. I'm looking for the differences. So that means I need to go back to stat edit and I need to go to the top of L3 and I need to subtract column 1 minus column 2. So second 1 for L1 minus second 2 for L2. And it populated all my differences. Now I can go stat calc 1 var stats, and I need column L3, so the second button followed by number 3. And I have a difference of negative 4.1 and a standard deviation of 12.827. So negative 4.1 and a standard deviation of 12.8274. All right. Well, now that I have my X bar, I can finish drawing my picture. And so this is negative 4.1, and this is my X bar. And anything that direction, I would have rejected. Okay, so now I need to plug into my formula. And so my formula is going to be T equals negative 4.1 minus 0, 12.8274 over the square root of 10. All right, let's go ahead and calculate this. Well, I need to go to stat test. It's just going to be a t-test. I have data. My mean is 0 because we hypothesized that there'd be no difference. My data is in L3 if make sure you place the second followed by the number 3. And my direction was less than. And when I do that, I end up getting a t-statistic of negative 1.01. And by the way, I should have probably done this. So I'm going to do it anyway. Probability that t is less than, and put that in parentheses. So this is the probability that t is less than negative 1.0107, negative 1.107, p-value of 0.1692. So my p-value is 0.1692. I have an alpha. They gave me an alpha value of 0.07. That's my significance level. This is greater. And when it's greater, the decision is to fail to reject. So let's state everything. Our p value is 0.1692. We fail to reject the null. There, be careful here, not enough evidence at alpha equal 0.07 to suggest that you got to restate all of this. True population mean of the differences in the number of shaves, generic minus name brand, is less than 0. All right, the less than 0 came from a restatement of my alternative. The mean of the differences is less than 0. And that's basically said mean of the difference is less than 0. And we're saying there's not enough evidence to say that. All right, that's what we're saying. There's not enough evidence to say that. So, in conclusion, not enough evidence to say the name brand lasts longer. All right. That last part in red wasn't required, but I just feel like it was really important to understand what we have. There's not enough evidence to say the name brand lasts longer. I sure hope this helps, and I will see you on the next one. Thank you.